Welcome back everyone to another LeetCode problem solving video. In today's problem, we're going to be solving an easy Amazon question. It should be a piece of cake if we get this in an interview, at least in the first round. But do we ever stop and think about real world case scenarios when we can apply these problems? Sometimes that could give us a little hint of the data structure we need, of a particular variable, a particular process we can create or use. Let's keep that in mind. Let's go ahead and jump into the video and see if we can get this job. People of YouTube, welcome back to another code problem solving video. Today we're going to be solving an easy Amazon question. I believe I would get very lucky, any one of us would be very lucky to get this question on our next interview, because just scanning through the problem, I don't think it should be hard for us to identify a couple solutions for it. But today we're going to be trying to implement obviously the most, let's say, interview ready solution. So let's go ahead and read the problem description. It says, given a string S containing just the characters, open and closing parentheses, open and closing curly braces, and square brackets, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. Okay, first example says open and closing parentheses, the output's true because the open bracket it's closed by the same type, and lastly the closed bracket corresponds to the same opening bracket. That's kind of redundant, I think, because it's going to have an open bracket of the same type. So I mean, kind of like a hint if you want, but really a little redundant on that third option there, but just me being a little. Anyways, let's jump into the second example. It says open and closing parentheses, open and closing square brackets, and curly braces. They open and close at the same order with the same type. And the first one here, that's false. It basically says opening parentheses, closing square bracket. So the third example here says opening parentheses, closing square bracket, and it returns false because it opens with one type of parentheses and it closes with another type of square bracket, right? So false, and this input would be true for the same case. It opens with this parentheses, then it opened with a square bracket, but it closes in the same order. Okay, so that's a good example for us. Constraints, very important. Some people like to jump these constraints and just go ahead and show you the polished code, which is fine. Okay, if you're looking for straight up solution, if you don't want to waste any time, this is a learning process for me. So as much as I want to provide value to you, I also want to make sure I'm going through the right processes in order to not make it a habit skipping things, because at the end of the day we're all preparing and doing LeetCodes because we want to become better at solving problems, but also become better at interviews. Okay, so skipping constraints sometimes is not the best option. Another cool thing about constraints is that I'm going to be providing on the links a cool cheat sheet I found. Basically, you can determine, based on the size of your input, the type of complexity you're going to have, time complexity specifically. And for instance, in this case, we're going to have a string all the way up from 1 all the way up to 10 to the 4, which is a very long string, obviously. But based on this, we know that we're going to need at least a linear solution, right? Because we don't want to get out of our bounds at time of execution, right? We don't want to get a time limit ending execution in our code. So that's a good thing to know. If the string would be, let's say, 1 all the way up to 10, if we only would have to worry about 10 characters, we can even brute force that solution, because the complexity won't be, the execution time of the code won't be too hard on the hardware or, any other platform we're executing it on, the cloud or whatever. But again, it's knowing that the efficiency of your algorithm, it's going to be based on input array, and that's why time complexity or input data structure, whatever, I said array just for the sake of it, but any input, the size of the input, that's what is important for us to know the time complexity. Okay, I found a cool sheet I'm gonna share with you on the description, so look it up, and if I forget, please let me know in the comments. Hopefully I don't. So the string consists only of the previous parentheses, square brackets, and curly braces or brackets we saw. These are curly braces or curly brackets. I think that's interchangeable. I might be wrong. That's perks of having English as second language, but who's counting that? So, easy problem, and I'm seeing that the acceptance rate is kind of low for an easy problem, and we also have hints here, so I believe, you know, some of these problems give developers a little bit of a headache sometimes. A good thing I like to do, and I show it at the beginning of the video, is to imagine these problems once I understand the problem completely. Obviously, with this problem, it's going to be easier than any other medium or hard problems, but apply that to a real time or a real case scenario, right? Where the valid parenthesis problem would be useful. And as I show in the intro, when we are using, for instance, I don't know, Java code, and we have a block of code that's, you know, defined by these two curly braces or curly brackets, we essentially know that the compiler it's going to be looking for that. So if we close our code with this square bracket, then obviously our compiler is going to complain at some point. So again, imagining real case scenarios for certain type of problems would help us to see where we're standing sometimes. And, you know, compilers would definitely use functions like this to keep order of that. So let's try to jump into a whiteboard, and if you just, you know, I'm making sure I have timestamps in the video, so just go ahead and jump into the solution if you just want the quick part of the code. But if you want to see the whole process of how we find the solution, then let's go ahead and check that out here in our Blackboard, okay? So first we know we're going to have a string of this type, okay? And let's use just this example right here. I'm going to say I have a parenthesis here, square bracket, and then I have a curly bracket right there, curly brace, the best I could do. And then I'm going to close that with a parenthesis, okay? So obviously this would be an invalid string, right? But let's go ahead and see how we can find this solution. At least we know that we can iterate over this string, and we don't have to convert this string into a list or any other data structure to operate in it. We also know that we don't have to do any type of rearrangement in this string or clean it, because we only are going to have based on the constraint. I'm going to scroll down real quick for that. We only have to worry about these characters. And what I mean by that is we don't have to clean the string. We don't have to worry about spaces. We don't have to worry about any other alphanumeric characters to solve the problem. So I think that could be one of the reasons why this problem is marked as easy. So first, let's say the first thing, obviously we have to determine which data structure do we want to start with, right? So we have to make sure that there's type and order, okay? So type is the same type of bracket being used, and also order, okay? I don't know why my computer is acting up a little bit. It's kind of slow right now. But anyways, we have to worry about type and order. And we're getting basically a raw string that we have to iterate over and make sure that it basically satisfies those three conditions. But mainly type and order, right? It has to be close, open and close by the same type of parentheses. And that's what we're going to be looking for. So using a real world scenario also is going to help to determine which data structure we can use. A good thing compilers use is stacks to keep order of things. So we can say that we can try to use a stack to keep order of parentheses. Now, but let's imagine this is a stack, okay? And that's how we're going to keep track of order, okay? Now, how is the order going to work? Because we're going to have parentheses that are coming in certain order, right? So we're going to keep track of that order. The first thing we need to figure out is, okay, what's going to make a valid string is the fact that it's going to be always starting with an open parenthesis, right? Because we cannot start with a closing parenthesis and then end with a open parenthesis, right? That's not the order we're looking for, even though they're the same type, right? They're both parentheses, but they are not in order, okay? So the first thing we have to look for here is that we are starting with opening parentheses, right? So I would say, you know, thinking about order, let's go ahead and assign a number here to that parenthesis. That's one open parenthesis there. Then we have a second open square bracket here, and then we have a third curly brace here opening, right? And then we find our first closing parenthesis. That belongs to number one right here, to the first parenthesis, okay? So, you know, first we see the order that they came in, and we're gonna make sure we start with opening parentheses. So the stack have to take care of order. What is the order we're looking for? Well, the order starts with opening parentheses. So we could say every time we see an opening bracket, square bracket, or curly brace, let's go ahead and add it to the stack. Why? Because that's how we're going to keep track of order. If we see, let's use another example here. Let's say string is going to be equal to closing parentheses and then opening square bracket. If we see this iteration, right? If we start here and it's a closing parentheses, we know that if there's no an opening parentheses on top of this stack right here, if there's no opening parentheses, then there's no order, okay? That's another hint to solve this problem. When we find our closing parentheses or brackets, we want to check what's on top of the stack, because the stack is keeping order, okay? And as we know, a stack is going to be removing in a LIFO process, in a LIFO order. So last in, first out. The element sitting on top is going to be the first element to go out, and that's what we want to take care of when we find our first closing bracket, okay? So let's go ahead and use this example right here. We find our first opening parentheses right here. So we said, okay, every time we find one, let's go ahead and add it to our stack. And I'm gonna use a different color to represent that better. We have our first opening parentheses. We iterate into the next one and we find a square bracket. So we add it there. And then finally, we add our opening curly brace. So cool. Now we know that in order for us to find something that matches, it has to be a curly bracket or curly brace. I'm gonna call them all brackets because I think I'm getting you guys all baffled on the other side with missing the names of these things. But anyways, we have to find now a closing curly brace, right? And in the next iteration, we find a closing parentheses. So we check if this parentheses matches the top of our stack, and since it doesn't, then we know immediately that is a false string. It's not a valid string, so it's false, okay? So that's a hint right there. That's a start. We know that we can keep order of incoming elements using a stack, because once we finish piling things up on that stack, in order for us to start working with whatever we finish on top of that stack, we need to match its element on top. Okay, so that takes us to the next part of this problem. So now we keep track of order. How do we keep order of type? Well, we have pairs of elements here. We have opening and closing square brackets, and opening and closing curly braces. Okay, so how do we pair these things? Okay, we could do this in multiple ways. We're going to keep order on one side using the stack, and we're going to keep track of types in the other side, okay? Because the stack cannot really take care of type as far as I can see, because unless we chain our last element with something on top of that stack, let's say create another data structure here parallel with that, and that obviously everything we push on top of that data structure that has to match what's here, but that would complicate things a little, okay? Because we're talking about basically merging two data structures and finding a pair there. So let's go ahead and separate that, break that into a smaller problem, and let's say, what about if we create a dictionary, right? Key value pairs, okay? That's an idea. Also, for efficiency, we can use sets. Why? Because we only have to deal with 6 elements, okay? We're not talking about we need to worry about all the alphanumeric characters and spaces and things, right? If that's the case, then maybe a dictionary would be better and we would have to look for other type of solutions. So in this case, we could say, let's create a set of pairs, and that set is gonna take care of type. How? Well, we're gonna initiate our set, right? Or we're gonna initiate our stack. The stack, when we initiate, it's going to be empty, and the set is gonna contain all 6 elements, because we want to make sure every time we find a closing parenthesis or a closing bracket, it matches our pairs, okay? So how do we do that? Okay, let's go ahead and check iterations here. So let's say we have this string here. Again, let's go ahead and take this example here. So we start iterating over this string. The first element, it's an opening parenthesis, so we add it to the stack. The second one, square bracket, we add it to the stack. And finally, we find our opening curly brace, so we add it to the stack. We find our last element in the string, and it's a closing parenthesis. So what do we do here? Well, how do we know it matches? Okay, because in order, we know it's not there. The order doesn't match, but the stack doesn't know that, because the stack doesn't have any reference to compare anything, right? The stack only knows what's on top, okay? So we have to build that comparison. And how we're going to do that? That's where the set or dictionary, you could use either or in this case, but I like to use the set, a little more efficient for worst case scenario. That's one thing. But the set is also going to help us to compare. So what we're going to say here is, okay, we found a parenthesis here. Is the parenthesis and the last element on the stack part of our set? Well, let's see. Do we have an opening curly brace and a closing parenthesis in our set here? We don't, okay? Because we only have matching pairs, okay? So immediately we know that that's a false or an invalid string. Okay, so let's try that out now with a valid string to see how this is going to work, okay? So I'm gonna use a simple example. I'm gonna have a opening square bracket, curly brace, and square bracket, okay? So this should be a valid string. And let's go ahead and use our example. So we're gonna create a valid set that's going to contain the pairs, okay? And the pairs are valid parentheses here, square brackets, and open and closing curly braces, okay? So we create our set, and we're also gonna create our stack. Our stack at this point is gonna be empty. Stack is gonna keep track of order. Set's gonna keep track of type, okay? So first iteration over the string finds an opening square bracket, add it to the stack. Second iteration finds another opening, a curly brace, add it to the stack. Okay, so now we hit our first closing bracket. What do we do? Well, we have the top of the stack, and we also have a set of pairs here. Let's build something and compare and see if it satisfies the solution. So let's ask, it's the last element in our stack, meaning the top of the stack, and our actual element in our iteration, meaning a closing bracket, part of our pairs. Well, yes, it is. Then we go ahead and pop this element right here. Okay, so that is the third part of our problem. Once we find a valid pair in our set, then we can go ahead and pop that element, removing that element from the stack, okay? Leaving our next, we're keeping track of order here, leaving our next opening bracket. In the next iteration, we find our closing square bracket here, and we ask the same question. Is the top of the stack right here and our last element part of our set? Well, yes, it is. What do we do again? Well, we go ahead and pop that element. And finally, the stack is empty. We finish our iteration. We finish our loop, and we ask, is the stack empty? Well, if the stack is empty, then the string was valid, and we can return true because we went through all elements of the string, finding all possible pairs, and we were able to clear out our stack, okay? So we keep track of order, we keep track of type, and we finally return a valid string, okay? So let's go ahead and jump into our code and see how we can solve that. So we said we're first gonna let's go ahead and create an empty stack. We're just gonna name it like that, and it's gonna be a list in Python. That's how we create stacks, basically, right? Let's go ahead and create our set that is going to be named pairs, because we want to have certain pairs here, and I'm gonna have basically opening, closing parentheses. Pairs in Python we can set inside our dictionary type curly braces, and also we're gonna have square brackets right here, and finally we're gonna have opening and closing braces. Okay, so what do? Now we have the stack and we have the pairs. We don't need indices or indexes here, so let's go ahead and say for every character in our string, if the character equals, well, let's say if the character is in one of these three opening options we have, if it's part of one of those three characters, right? If it's an open bracket, let's go ahead and add it to our stack. Okay, quick pause here to talk about this example. So this is our new string. Just imagine we have two closing brackets. The stack is empty. We haven't added anything because this is our new string. In our first iteration, we find a closing bracket, but our stack is empty, meaning there's nothing to match what's on top of that stack, okay? So if that's the case, then we can say in our code, if not stack, this is just shorthand to ask if the stack is empty, or I should say the way I type stack. If the stack is empty, or, and this is where the set comes in handy, we could say, or we're gonna pop the last element in the stack in case the stack is not empty. So if the stack is not empty, remember that the pop operation in Python returns also that element. So we're going to return that element plus our current character. So what we're saying here is we're building what we were doing here earlier, and it's basically we're saying we're dragging this element from the top of the stack, right? We're saying if this element matches this character right here, this is our character from our current iteration, and this is our element on top of the stack. Okay, so that's what we're doing here. We're popping that last element on top of the stack, and we are merging it with our actual character, right? If it's not in our pairs, in our dictionary pairs, then we can immediately return false. Okay, so basically if the stack is empty or the last element in the stack plus our current character is not part of our set or pairs, right, then we return false. Now if we go through the whole string and we are able to remove all those elements, then we can safely say return not stack. So basically we're saying if the stack is empty, return true. If the stack is not empty, it will return false. Okay, and before I run it, I'm going to make sure I add the character there, okay, before solving that problem. So let's make sure that's there. So we're saying for every character in the string, if the character is an opening bracket, then go ahead and append it. If it's not, then let's make sure the stack is not empty, because if it's empty and we haven't finished going through our string, it means there's no opening bracket to match the closing bracket we just found, or the last element in our stack or the top of the stack in our current element is not in our pairs, in our set of pairs right here, then we can immediately return false. If we go through the whole loop and we happen to have an empty stack, then we return true. If not, then we return false. Let's go ahead and submit that code and let's hope for the best. We are confident we can get accepted in Amazon, and we did. It's cool sometimes when we see beats 100%, then you see the 67% of solutions did the same thing. But yeah, this is our solution. I hope you enjoy this part of the code, and we're here getting better every day. If you like the video, please thumbs up, subscribe. I'm gonna be solving more problems, and hopefully one day I'll be able to tell you guys that I landed that dream job in big tech. This is the video. I hope you like it. See you in the next one.